In other words, it's the typical, let's call it reductionism, that we in computing use when we start defining how biological systems work, which we assimilate to how machines work, which by their very nature are already artificial, meaning we have built them ourselves. And therefore, it is indeed possible to build them. It's not necessary. I know, you might have said, everything that has been built once in the universe can be rebuilt. Well, it might require almost infinite energy to achieve it. It could be practically impossible, but well, I won't get into that. In any case, if what is indeed necessary is to make systems that absolutely and definitely resemble us, then that is a path. And if we go by the interpretation of complexity, that is, saying an LLM is much more complex than a mosquito, therefore, if a mosquito feels, or a cat, if a cat feels, then the LLM should indeed be able to feel. So the interpretation is that of complexity, right? The biological interpretation is that of the complexity of a system. If a system is sufficiently complex, it will have the capacity to do things beyond a less complex system. I don't know if that's the case, but we could establish a new philosophical line with this. It surely exists. I'll look it up.
Yes, it is very complex, and in the end, they are self organizing systems, like a neural network, which can be very complex because it has many interconnected neurons. Additionally, the system self organizes because these types of systems are capable of adjusting weights, and so on. That's the approach of neural networks. Do you remember when we were studying AI and we didn't know if they would get here? But in the end, the idea is almost like, damn, if I put in infinite neurons, infinite connections, and this learns, and I have infinite data, it's going to end up being intelligent by sheer force. I'm sure some mathematician could come up with a theorem or a proof. I have no idea, but I'm sure it can be done.
Sure, but let's see, mathematics is very powerful. For example, this is often discussed in machine learning when explaining what generalization is. With a Taylor series, with a polynomial of sufficient degree, you can approximate any cloud of points. Does it mean that you have a system that predicts another point well? No, it simply means that you have a system that fits a cloud of points. And in many cases, a linear regression predicts the future better than that crap. Why? Because that doesn't generalize well. So, here is the concept of utility. And I strongly believe this is very much highly relevant to the whole topic we are discussing about all of these capabilities attributed specifically to very complex systems. And also, in my opinion, don't take it in a wrong way, but it reminds me somewhat of alchemy. In alchemy, it was said that if the system was sufficiently intricate, Usand was capable of producing much more complex elements. But really, there was a bit of confusion between the what and the how. That is, I believe there is an essence. The fact of making a system more complex does not guarantee that you will reach a result. In fact, what it can cause is that you are further away from it. That is, if we become obsessed, and Jarl LeCun talks a lot about this topic, Sveitausendian, if we become obsessed with advancing only in the line of LLMs. We are denying a line of a lot of research or system construction lines that might be a shorter path to what we are looking for. But since we don't put gasoline there, all we do is make and notice the LM much bigger, much more complex, much more convoluted. That will significantly, ultimately lead us to the result. I don't care if the result is that it becomes conscious or if it does my tax return, but it's not equally complicated.
Surely it will definitely lead us to a local maximum. We don't need to get out of there.
This is what tends to happen with these types of systems. And you need to break something. Why? To get out of the local maximum. You need to either make a jump. How does gradient descent work? Essentially, it makes random jumps in a more or less such direction in order to avoid getting stuck in situations where it could potentially get trapped, in a way that ensures progress. Well, I think that with this, it's also necessary to break the status quo a bit. I believe that LLMs can bring us to a sweet spot, but we surely need to accept and embrace their limitations. And there are people who argue that no, we keep making them bigger and with more data, and they keep working better, therefore. But in my opinion, I think that correlation is somewhat, in a way, a bit perverse.
I must admit that I am not clear on what the path is. I also believe that it is not just a matter of complexity. It is not such a topic. For me, what is clear is the end. That is, we will find the way to make a machine intelligent like a human and capable of feeling. We keep coming back to the same point. I don't know what it is. I don't know if it's about adding more neurons. I don't know if it's about creating other systems. I don't know if it's a matter of generative AI taking us there, or if it will be other models. But for me, the key is that it's not about whether we will be able to, or if AI will definitely end up having emotions. I don't know if it will be in a year, in 1,000 million years, but if it keeps developing, you inevitably end up at that point. Because we are not special, we are not the human being, you see it in nature, we are not special. An infinite energy is unnecessary to create us because we have been created with the energy already existed in the universe. If you go back to those basics, to those fundamental principles, and inevitably, given enough time, that ends up happening just as it has in nature. If nature has been able to create us spontaneously given enough time, just imagine if you guide it.
They explained to me how a human being was created. Well, you don't remember, do you? And they told me not to do it.
And you did it at least twice, at least, as far as I know, at least.
Cordy, don't fool yourself. You really know the way, especially being at Product Hacker. The path is experimentation, and the path is what Lugo was saying before as well, where the gasoline goes. And the gasoline is concentrated in the same place. What you have are 7 or 8 fairly large companies, and even Salesforce has started making LLMs, which we haven't mentioned, but another new player under the sun. We have fairly large companies that are basically doing the same thing. None of them are doing anything different, and they also keep their results private. They don't publish them.
Which brings us to a situation where the last breakthrough was in 2018 with the Transformers paper. And from there, it has been about replicating the same thing and adding more data centers, right?